Today we're talking about parabolas. There's this thing, and then there's this focus and directrix, and then here's the formula in the book going sideways, and we're here now. Okay, so now we're going to look at this parabola and try to identify the focus point in the directrix. It looks like it has been shifted, and it is a parabola because we identified that the variables, one of them is squared, one of them is not. And so because the x is the one that's squared, we're going to assume that this parabola is opening upward or downward. I guess you can also look at the sign here, and the sign is positive, so we know it's going to open upward. But how are we going to make it look like our general formula? What do we need to do? Yeah? Hey, complete the square. So I'm glad you guys had a chance to think about that a little bit, because now you remember how to complete the square, right? All right, so how do we complete the square? So looks like we won't touch anything on the other side unless you want to add, subtract to both sides or whatever, but it doesn't matter how we do it. Before you do anything with this, I think one important step to take is to, well, I'm going to regroup this first, and I'm going to leave the 27 out here. We could have dealt with the 27 also because it looks like it's a multiple of 9, but we'll, in general, we'll leave that out. And then we'll rewrite this just so we can work with it in the next step. So in the next step, we're going to factor out a 9. And then I'm going to leave a little space here for the thing that we're going to add and subtract. And you know, when you add 0 to something, then it really doesn't change your equation. So that's essentially what we're going to do. We're going to add a number, but at the same time we're going to subtract it, so it looks like we're adding 0. So the number that we're going to add, I think it's going to be taking a look at the b term. And when I say the b term, is a is equal to 1, b is the number, the multiple of x. It doesn't matter where you take it, negative or positive, because you're going to square it anyway, so it'll be positive. So it looks like it's 1, and then you're going to take that b term, you divide it by 2, and then you square it. And then this magic number is going to be what will complete the square. So in this case, we're going to add 1 in here. Now, we have to be careful when we're adding and subtracting on the sides that we didn't really add a 1, right? What did we really add? We really added 9 times 1. So we really added a 9, and so since we added a 9, we should, to keep this the same, we should subtract the 9. So that is how we're going to do this. We now have a completed square. And you know how to complete the square. Once you know it's a perfect square, you take the middle term, and then you take the square root of the last term. And then you know that's a perfect square. You can always FOIL it out to make sure that you're doing it correctly. 36 is our other equation. So now, at this point, I can probably graph the parabola more or less using techniques, because now using techniques of stuff that we learned in pre-calculus. But we kind of want to make it look like this somehow. And so I think we're going to subtract out or add a 36 to both sides maybe. So y plus 36 and then divide by 9. So now it kind of looks like this. You got h is equal to 1. It looks like k might be equal to 36, and then we just have to figure out what 9 is equal to, or what p is equal to. So we'll deal with that. We're going to set 4p equal to 1/9, and then p is equal to 1/36. Is that right? I hope. Okay, so provided that that's correct, we have a shift over here. Now, I guess there's still a little bit of an issue because we did shift. This is a formula in general, how the formula might look like. But because we shifted, then we should expect this to shift also. Remember that this parabola is opening, which way is it opening? Up. It's opening up, right? And it got shifted to a new point 1,36, so it's way up there. Because your new center point, let's identify the center point here. Your vertex is at 1,36. Because your vertex is at 1,36, then we should expect our focus and our directrix to also shift. Right? Oh, -36, yeah. Thank you. I was going to say, sometimes I make mistakes on purpose to keep you guys awake and stuff. I think I made way too many mistakes to say that they're all on purpose. But I'm glad you guys are paying attention, because I'm not. I'm just cruise controlling here. All right, where are we? Oh, so the focus point. The focus point, based on this, should be 0, p or p, 0? 0, p, right? And p was 1/36. So having a directrix at y equals -136 and having a focus point at 0, 1/36 doesn't seem reasonable if this parabola had moved from its initial 0, 0 vertex position to a new vertex. It looks like that's not correct. So we need to use the shift to adjust the vertex and the directrix also. So what do we need to do to the vertex, or not the vertex, the new focus point? So the focus has to take into consideration the shift, right? So the focus is a point that got shifted in the x direction and in the y direction. So the shift has to happen for both the x and the y. So the shift is going to be 1. You have to add 1 to this, and then the shift in the x direction added 1 to it. The shift in the y direction went down -36. So whatever this turns out to be should be your new focus point. Now the directrix is supposed to be y equals -36, right? But then there's a shift. Now, do we need to take the 1 into consideration? Because the 1 is the horizontal shift, right? It moves this. It moved it 1 unit to the right. So the moving the parabola in a horizontal way is not going to change the directrix if the directrix is a horizontal line. So the only thing that we need to worry about the directrix is the shift. So it's The new directrix then is going to be minus 1 over 36, and then with a shift of negative 36. So whatever that turns out to be. Okay. I do it right? Let's take a look at a picture of this. So my parabola looks like y is equal to 9x squared minus 18x minus 27. Hard to see this. Let's zoom. Now, because I zoomed and compressed this y direction, 1 over 36 is going to be really, really small to look at. Oh, you know what? Maybe we can unzoom it and just look down here. All right, so that's our new vertex. It got shifted there. Now, if we draw a point, what was the point? 1 comma, what is it? The new focus point.
1 comma 1 over 36
So again, it's really close. It looks like it's the actual vertex, but if we zoom out enough, you can see that it's not actually touching it, right? And our line, what was our line again? Y equals, what was it? Negative 136 minus 36. So maybe I'll so here's the relationship between the parabola and the new focus and directrix that we just found, and it looks like it's where it's supposed to be. Right? So, is that okay? All right. I guess we should try to sneak this picture in. Oh, what? It doesn't want to go too low. How about a new page? And we can actually identify the important points. We got our vertex, 1 comma negative 36, and then 1 over 30, what is it, 1 comma and then the line, negative 1 over 36. All right. So that's your parabola business. Okay, we have to try to get through the other stuff. The next conic section graph to look at is the ellipse. So let's take a look at the ellipse. And so I don't know if you guys have seen this, and they do this in grade school sometimes now, or in high school, where they put a couple of nails on a board and then they tie a string around it. Have you guys ever seen that or done that? So the idea is that you got a couple of nails here, and then you tie a string around it. And then what you do is you take a pencil and then you pull the string tight. And then you pull it tight over here on this side, you pull it tight over here, and you pull it tight over here. And so if you keep drawing this thing around this board, you would get not a circle, but something that's kind of a circle elongated. And so that's the ellipse. So the ellipse is defined by the distance from the one special point to the graph, and to the graph to the other special point. If you add those two distances together, you have a fixed distance, and then you do that for the other points on the ellipse, that distance is going to be fixed. So hence the string business, because the string isn't going to stretch. If you use a rubber band, then it's probably not going to work very well. So if you use a string, that'll work better, and that'll help you draw out your ellipse. So the ellipse has an equation that looks like this. X squared over a squared plus y squared over b squared is equal to 1. Now that's just the standard form. Your ellipse might look more like the last problem in the warm-up there or something. But the idea is that you get something like that, and if you can identify that both the x and the y are being squared, and one more thing about that, the x and y are being squared, and they both have the same sign on one side of the equation, then you have yourself an ellipse. And somehow, some way, you can rewrite that equation into this equation. Well, with a shift that the book doesn't talk about until a little bit later. So that's the story behind the ellipse. It turns out that these points, these special points, are called the focus points, or foci. And so you would get the foci by putting this combination of A and B together. And this, by the way, is an ellipse centered at the origin. Let me switch the order here. So let's make the note of that. So if we take a simple example, like maybe x squared over 9 plus y squared over, I don't know, 16 equals 1. Oh, A has to be bigger than B. Sorry. Let me change the 9 into a 25. Then we can easily mold this into this this formula, and we say A is equal to 5, it looks like, and B is equal to 4. It looks like A is bigger than B. And so what we need to do is we need to figure out what c is equal to find the foci. So c squared is equal to 25 minus 16. What is that? 9? So c is equal to 3. And then the graph of that will have the vertices at positive and negative a, comma 0. And sometimes they call this the major axis. X is going to be the major axis. And then y is the minor axis, or semi-minor, semi-major. Oops. So the vertices on the major axis are positive, negative 5. There's also vertices on the minor axis, and that's going to be 4. So from there, you can essentially draw the ellipse. And then now you can identify your focus points. And this turns out to be at 3. So your foci is going to be at 3, 0, and at negative 3, 0. Okay? So now if you imagine a shift there, then you can figure out how things are going to shift. There's going to be a shift in the x and the y, then there's going to be shift on your foci and your vertices as well. So let's try to do a problem with a shift. Any questions about this example? Kind of follows the formulas pretty easily, right? So now let's extend this idea to a shifted ellipse. And then if you have a shifted ellipse, then you can imagine your focus point's also going to shift, right? Just by adding h and k, h in the x and k in the y. Your vertex, your semi-major axis, major and semi-major axis will also shift, so we can figure that out. So I think that last warm-up problem might be a good candidate for an example, so let's try that. X squared plus 3y squared plus 2x minus 12y plus 10 equals 0. So we're going to put all the x's together and the y's together, and if you want, you can throw this constant on the other side. So we can approach it that way. Just remember, if you're going to put things on both sides, then you're going to add on both sides. If you keep it all on one side, you add and subtract on the same side. Okay, so let's bring this over to the other side. Let's group up the x's and the y's together, and maybe do a couple of other steps along the way. So my x's are together, my x's are together. I'm going to leave some space here for the stuff that I'm going to add on. My y's will be together, but I'm going to take an extra step and factor out a 3. And so when I factor out a 3, this becomes a 4y instead of a 12y. Again, leave that space there, and then I'll take the 10 over to the other side, so it becomes a minus 10. All right, what are some of the magic numbers here? This is going to be 1. Half of 2 is 1, squared is 1. So you add 1 on one side, you're going to add 1 on the other side. The next number is 4. 4 divided by 2 is 2. You square that, you get 4. So you add 4 to both sides. Well, you're adding 4 inside here multiplied by 3, so you're really adding 12, right? And so I'll add 12 to the other side as well. So what do we have? We have x plus 1 quantity squared plus 3 y minus 2 squared. Remember, it's the square root of that last number is equal to 3. Right, so close, except we want this right-hand side to be 1, so let's just divide both sides by 3. X plus 1 squared over 3 plus y minus 2 squared over 1 is equal to 1. So you can see that a here is equal to, what's a equal to? A is equal to the square root of 3. What's y equal to? Or b. What's b equal to? B is equal to 1. And so we can figure out what c is equal to, right? By squaring it and then what is it? Subtracting it. So c is equal to a squared minus b squared. So this is 3 minus 1 is 2. That's c squared. So c is actually square root of 2. Is that right? All right, so that's going to help us find our focus points. But now our new center, our center isn't 0, 0 anymore. What's our new center? What? -1 comma positive 2. That's our new center, right? So from there, to get to the vertex, so imagine, I don't know if I want to do this, but I'm going to do it anyways. Imagine this thing, a is equal to square root of 3. Square root of 3 is about what? 1.5, 1.57, something like that? And then your b is 1. So this is your ellipse centered at 0, 0. But now you're going to move your center to -1 comma 2. So -1 comma 2. So you're basically going to take this ellipse and move it up there. So what does that mean? That means now you have a new major axis and a new semi-major axis, right? That's moved -1 comma positive 2 with a new center. So you're going to be interested in finding these 4 points to get the ellipse, and for the sake of answering some of the questions in your problem set, you're going to be interested in finding the focus points as well. And they all got shifted by -1 in the x and positive 2 in the y. So you take all the points that would have been, so your new vertices would be, well, this one started off at square root of 3 comma 0, right? Square root of 3 comma 0, but now square root of 3 with a -1 shift, and then 0 with a +2 shift. And then you have the other side, -3 square root of negative square root of 3 minus 1, and then 2. So that's your new vertex. You can find the other minor vertices, and then now you can find the focus points as well. And so the foci used to be at square root of 2 comma 0 and negative square root of 2 comma 0. Now they're at square root of 2 minus 1 comma 2 and negative square root of 2 minus 1 comma 2. Okay? Any questions? So the only other thing to worry about ellipses are that this made a point about our ellipse where A is bigger than B. If B was bigger than A, then the ellipse would be elongated vertically. It would be stretched out vertically. So that's the only difference. So for that, I'm just going to copy the next box, which again, I don't like the way they denote this, because what they do is they switch to A and to B to try to keep it the same. But all that means is that your vertex your vertices and your foci are going to be along the y-axis. That's the only difference. Well, that's the thing, is that they switch this, and so it's still a squared minus b squared. What? Yeah, yeah. Should I fix the notes? All right, I'll see what I can do. So if we keep the a squared and b squared the way it was before, and this time we say that b is bigger than a, then b squared minus a squared will be c squared. I think that in terms of your question, that would be a little bit clearer. Okay? All right. Well, we have one more conic section to look at, and that's conic section figure to look at, and that's the hyperbola. So let me just put up the formulas for that and maybe do one quick example. And the difference between the parabola and the hyperbola is that the x squared and the y squared have opposite signs. Again, they do that switch here with the variables that makes it a little confusing. So let me just highlight one of them and then maybe put the notes for the other one later. So if we take that same example, except put maybe a negative sign in front of the y squared or something. What was our example again? X squared plus, no, let's put, this is where I want to put a minus sign, minus 3y squared plus 2x minus 12y plus 10 equals 0. Maybe let's make this a minus 10. So it's almost the same. I'm just switching little things around. So if I do this, when I complete the square, the y squared is going to be negative, right? So let's go through the process quickly of completing the square. You got x squared plus 2x, again, like we had before, minus 3. This time I'm going to take out a negative, and then it says it's going to be a y squared. This negative came out, so it becomes a positive 4y. And then I just want to make sure that the right-hand side's positive, so I made this a negative, so it goes up on the other side, positive 10. And then now what do I have? I add 1 to both sides, and I add a 4 here, which is subtracting. Oh, that's still not positive. Damn it. Let's make this 20. Let's change this into something that will make it positive later on. So I added a negative 12. Right? So now I want to change this. What would make this positive 3? 2? I want this right-hand side to be positive 3. If this original problem had a 2? Okay. So if the original problem had a 2, the right-hand side is going to be a 3. All right, good. So anyways, I have x plus 1 squared minus 3y plus 2 squared is equal to 3. And so I have x plus 1 squared over 3 minus y plus 2 squared is equal to 1. Say again? So what should it be? This should be 14? Man, you guys taking notes in pen? Now is it equal to 3? I had at least 2 people say yes on the other one, so. Okay, so now we have a hyperbola, and we can kind of look at the vertices the same way we look at the vertices for the other one. So it looks like the A is bigger here. You know, look at the vertices for the A. Actually, it doesn't matter where the A is, but so this is a positive one. This is a negative one. So this positive in the X, negative in the Y. So positive in the X means we're going to look at this as your A value. So A is going to be equal to the square root of 3. And this is going to shift. So I'm going to draw the parabola at home first at 0, 0, and then I'll shift it. So A root 3 and negative root 3 has vertices here. These are vertices. And so your hyperbola is going to be opening sideways. Now, how are they going to open up? It says here they have asymptotes at B over A. Now, that's kind of, to me, that's kind of confusing. And so what I'd like to do is I'd like to look at, not that one. Look at your B. What's your B equal to? B is equal to 1. So draw a 1 here. I mean, this will end up being the same thing. And so what I like to do with the hyperbola is draw a box that has those values and then draw your line. It's essentially doing the same thing. It's drawing a line with a slope of whatever that slope is. And so that will end up being your asymptotes. Okay? So we need to move this. Where's it going to go? Where's the new center? Negative 1, comma 2. So the center, and I'll put the center in quotes because it's kind of like the middle of the hyperbola. Negative 1, comma 2. What? Negative 1, comma negative 2. So -1, comma, -2 would be somewhere over here. And so you can imagine taking this hyperbola and moving it down. I mean, you can imagine those boxes and those lines moving also, but I think if you could do that shift, that would be fine. All right. Okay, so Michael was supposed to remind me that you guys will have a quiz tomorrow, or not tomorrow, but next week, probably on Monday. And your quiz will probably involve parametric equations and polar coordinates, and it may ask you to graph, or it may ask you to match graphs or something. So I will allow calculators, so I hope you are going to be proficient with using your calculator. All right, that's it. See you guys next week. Is there anything else I forgot? No. What? More desks. I don't know if I want to keep doing the warm-ups. I started to grade them the other day, and that was a pain in the ass. So, I don't know. I'll think about it.
Have a good weekend.
All right, you too.